everyone, welcome to Learning at 11th Hour. In this video, I'm going to discuss about programmable logic devices and I'm going to tell you the different types of PLDs that are available, the advantages of using PLDs, and we are going to specifically look at how we can use the PROM. PROM stands for Programmable Read-Only Memory. With that brief, let's dive into the video. So, PLDs or Programmable Logic Devices are basically electronic components, and these components are used to build reconfigurable digital circuits. So, that is the major difference between a combinational logic circuit and a reconfigurable logic circuit. So a combinational logic circuit, we know what is the output that is going to come out from the circuit for a specific set of inputs. Rather, we know what is the function that it is going to implement even before we rig it up. Whereas in case of PLDs, we do not know what function it is going to perform or what is its behavior going to be at the time of manufacturing. So the PLDs can be programmed and they can provide a variety of different logic functions. The internal connection of the PLDs, it is configured by the programming process. The simplest technology used for programming PLDs is with the help of fuses. The fuses can either remain intact, which is the normal condition, and if you want to program it, we need to burn these fuses, which means that it has been programmed. Now, normally, the PLD is made up of two sets of arrays. We have the AND array and we have the OR array. So if we provide the input over here, we get the output at the OR array. Now, depending on whether these arrays are programmable or not, we have three types of PLDs. So the first one that we're going to look at is called the PROM. And in this, the AND array is fixed and the OR array is programmable. PROM, as I said, stands for Programmable Read-Only Memory. The second case is where I have the AND array and the OR array, and in this case we have programmable and fixed OR. So this is basically called as the PAL. PAL here stands for Programmable Array Logic. The third type is called PLA, Programmable Logic Array. The Programmable Logic Array is where both the AND as well as the OR array are programmable. So this is also programmable, this is also programmable. None of them are fixed. So using this information, we can actually use these devices to implement logical expressions. Like how we used the multiplexer to implement logical expressions, we can also use the PROM, PAL, and PLA for implementing logical expressions. Let's look at this example where we've been given the Boolean functions f1 and f2 that depend on two input lines A and B, and we have been asked to implement this using the PROM. So as far as the PROM is concerned, from the AND array, we are going to obtain all the possible minterms that are there. So in this case, we have only two inputs. So the possible minterms are A dash, B dash, A dash B, AB dash, and AB. So if I want to implement this, this is A I will need a complemented version of it, A dash. This is B, and this is going to be my B dash. So all the minterms are going to be available from the AND array. So let me draw 4 lines here, one for each minterm. So the first minterm is A dash B dash. So I'm going to put a dot in the A dash and the B dash line because this is A dash and B dash. So here it means this symbolizes that here I'm getting A dash B dash. Of course, I'm going to use a AND gate over here to represent this AND symbol. So the second minterm is A dash B. The third one minterm is AB dash. So here and here. And the last one is AB. So since the AND array is fixed, that is the reason why we are using the dot as the symbol to show how we are getting these minterms over here, right? So at the output of these AND gates, what we are getting is all of these minterms. So here we have A dash B dash, here A dash B, A B dash and AB. Following this, we need to implement the programmed OR array. So in this case, we have two functions F1 and F2. And here all the minterms are available, meaning this is minterm 0, 1, 2 and 3, of which F1 has only 0 and 2 in its function. So F1 has to be programmed only for minterm 0 and 2. And we are going to use the OR gate to tap out the output. For implementing F2, we need to program the lines with minterms 1 and 3. So here, let me draw another line which represents the function F2. And here we are going to program 1 and 3. We are going to use the OR gate to implement the function. So effectively, this particular configuration means that from here, we see that this is the AND array and the dots represent that the AND array is fixed. The cross represents that these are programmable. And therefore, we've used the cross to symbolize it, and we've used the OR gate to frame the OR array. Put together, here F1 means that minterm 0 and 2 have been programmed into the OR gate, and for F2, we have programmed minterm 1 and 3. So this is how we use the PROM to implement any Boolean function. The only thing we need to remember is we are going to frame the AND array in a fixed manner such that all the possible minterms are going to be available to us given all the inputs. So if we have 3 inputs, if a function is made up of say 3 inputs, in that case we will have 8 such combinations. So we should have 8 minterms in that case. And from those available minterms, we need to program the necessary minterms which make up the particular function that we need to implement. So that's all with today's video. I hope programming or implementing a Boolean function with the help of PROM and the basics of PLDs is clear to you all. If you have any queries, please do not hesitate to post them in your comments. Thanks a lot for watching.